Good morning to all gathered here. Welcome to day 2, session 3 of the Faculty Development Program on Recent Advancements in Materials and Manufacturing, RAMM. Before we start with session 3, I would like to read out few housekeeping rules to be followed for the day by all the participants. All participants are requested to mute their mics. Participants are requested to use the chat box for any queries and questions to be asked to the guest speaker. You can post the questions during the session and it will be answered during the question and answer session. Please send your questions to the everybody option in the Zoom chat and not directly to the presenter. The participants can also unmute their mics after raising their hand option in Zoom to ask their question to the speaker during the question and answer session. The materials of this session by the speaker will be made available to the participants on the speaker's discretion. The recording of the section will be available on SJAC YouTube channel in a week's time. Feedback link will be shared at the end of every Q&A session. Please fill it and it will help us to improve in our future sessions. Certificates will be provided to all the participants only if their presence and feedback to all the 6 sessions is provided by the registered participants. I now request Dr. Raju K, Professor in the Department of Mechanical Engineering, SJAC, and the convener of this online FDP program to introduce our guest speaker, Dr. Samuel GL. Over to you, sir.
Thank you, Noel. Very good morning to one and all. It's my pleasure to introduce today's speaker, Dr. GL Samuel. Dr. GL Samuel is currently working as a professor in the Department of Mechanical Engineering at IIT Chennai. He obtained his PhD from IIT Chennai and later his postdoc from Kyungkook National University, South Korea. He was a visiting faculty at the Department of Mechanical Engineering, University of North Carolina, US, Deakin University, Australia, Politecnico di Milano, Italy. He has received many awards and also he has received project grants worth of rupees 11.5 crores from granting bodies like DST, CSIR, DHI, ARDB, L&T, etc. He is a member of many professional bodies. He has guided so far 18 PhD and 5 MS and 40 MTech candidates. He has published 2 book chapters, 2 book reviews. He has in his credit 3 patents and he has published 55 international journal papers and 60 international conference papers. Dr. GL Samuel's broad areas of interest in research and teaching are metrology, micromachining, unconventional micro manufacturing, and computer-aided inspection. For any further information, you can interact with Professor GL Samuel during question and answer session. And also you can log on to his personal webpage at IIT Chennai for further information. With this, I conclude my speech and I request Professor Samuel to take over the session. Over to Professor Samuel.
Yeah, good morning to all. So I see some of the familiar names there. Actually, the instruction is that you can speak only toward the end, but I think it should be fine if you'd like to introduce yourself so that I can know who you are and then I can pitch my lecture based on that. Is it fine, Professor Raju and others?
Yes, sir. It's fine, sir.
Yes, sir.
Okay. Yeah. So can we just have a short introduction to know the cross section of people who are attending?
Good morning, sir. This is Sriranga Bhatta from St. Joseph Engineering College. Right now, I'm heading the department, sir. It's great to meet you, sir. Thanks a lot for coming over here, sir.
Oh, thank you. Thank you. Yeah, others, participants.
Participants, you can feel free and you can interact with the speaker. You can introduce yourself.
Yeah, at least few of you.
Yeah, good morning, sir.
Yeah.
This is Dr. Rosan Kumar,
Come
Head
this
of
side.
Mechanical Engineering Department, Barris Institute of Technology, Mangalore.
Oh, okay. So Mangalore. Yeah. Yeah. Without wasting time, I think you can quickly introduce.
Good morning, sir. Myself, Sudhiriam. I'm right now professor in mechanical engineering and Dean Academics in St. Joseph Engineering College, sir. Host Institute. Yes, sir.
Oh, thank you. Nice.
My
Thanks for
research
joining.
area- Yes, thank you, sir. My
Yeah.
research area includes polymer composites and its characterization, sir.
Oh, good. Yes, sir. Thank you. Next. Yeah.
Good morning, sir.
Yeah.
This is Kenyon Sherwin from St. Joseph Engineering College, Assistant Professor in the Department of Mechanical Engineering.
Oh, okay. Thank you. Welcome.
Good morning, sir. I am Noel Deepak Shiri, Assistant Professor, Department of Mechanical Engineering, St. Joseph Engineering College. I am also the co-convener of this program, FDP.
Oh, thanks. Nice arrangements. I think you have all made. Yeah, that's good.
Welcome, sir. Other participants, you all can please introduce yourself to the speaker.
Good morning, sir.
Yeah.
I'm Govinda Krishna from the Department of Civil Engineering, and I'm the assistant professor working.
Oh, from civil department, is it?
Department. Yes, sir.
Okay.
Thank you, sir.
Yeah, you're able to follow our these things.
Good morning, sir.
Yes, sir.
Yeah.
There is some
Sir, myself, Dr. Ravichandran. I'm working in Christ University, Bangalore, Department of Mechanical and Automobile Engineering.
Oh, okay, nice. Yeah.
Hello, sir.
Hello, good morning, sir.
Yeah, one of you, please go ahead. Yeah.
Good morning, sir. This is Chittaranjan, assistant professor from the Department of Civil Engineering, St. Joseph Engineering College.
Oh, okay. Yeah.
Hello, sir. I'm Sachin from the Department of Civil Engineering. I'm working as assistant professor in the Department of Civil Engineering.
Okay. So we have civil engineers also. Okay, so we'll try to see that. Yeah, it will be catering to all the people. Yeah, please go ahead.
Hello, sir. I'm Dr. Ravi Kumar V, Global Academy of Technology from Bangalore, Mechanical Engineering Department.
Okay. Yeah, so we have from different places in Karnataka. Is there anybody from outside the state, Karnataka?
Yesterday, there were a few people from Rajasthan, Orissa.
Oh, okay.
Today, I think they are not yet to join it.
Okay, that's fine. Yeah, I'll just share the screen. So just one moment. Yeah, are you able to see the screen?
Yes, sir.
Are you able to see the screen?
screen, but nothing is there. You have keep it out. Now, yes, we can see.
Yeah, okay, so fine. So in today's lecture, we are going to talk about the smart manufacturing and its applications. So as we see that the participants are from different colleges and with the different backgrounds, so we hope you'll be able to follow what I am trying to say. So if you move back and then look at the basic aspects of manufacturing. So manufacturing is actually the backbone of any country. So nowadays, actually, you see all the government people have been talking about the manufacturing, and then they have been encouraging, telling the concepts like make in India, and then we need to develop manufacturing. And also when you look at the countries which we call as developed countries, so basically actually they have grown in industry and they are called as developed countries. So thus manufacturing actually plays a very, very important role. So countries like India, which were depending on the agricultural economy, are now shifting to the manufacturing as main source of the wealth or the income for the country. So thus we have been shifting. We are in the period where we are shifting from the traditional way of producing the wealth to the modern way. And also if you look at the manufacturing, this term is not actually new. So if you really go back and look at the meaning, so it conveys something differently than what we define as manufacturing today. Does anybody know what is the exact literal meaning of the words manufacturing? Yeah, you can unmute and speak. What is literally the meaning of manufacturing? Does anybody know?
Do something on our own, like for example, similar to manuscript, maybe.
Yeah.
Indigenously doing something.
Yeah, please go ahead.
Sir, in Greek, manus means hand and factus is handmade.
Yeah, very good. So that's what exactly I wanted to say. So manu and factus means made with hand. So, but now when you are talking about manufacturing, so we are actually going to look at the slides and the subject where we talk about making or manufacturing something without the use of hand. So thus the basic meaning of the word and the context what we are looking at and where we are using are entirely changed. So how all this manufacturing, everything has started. So we say that it all started with industrial revolution and with what is called as mechanization. But actually that is also even not true. You know, even the people who were in the rock age, so I think we know the developments of humanity. So even those people who are not cultured, who doesn't know anything about the civilization, but still they used the stone implements. So they use the stone implements. So how does they know that? So now we know. So if you have a sharp tool, you can cut the materials. But even those days, actually, they knew what is machining. So maybe in a different form. So thus, manufacturing is not something new. It was there right from ages. But still, with the Industrial Revolution, so it has taken an entirely different shape. And today what we are because of those developments. So now if you look at one of the invention, so where James Watt, he was able to invent the steam engine. So it may look very, very simple and the mechanism is also not that great, but the way how it revolutionized the way how people started doing is entirely different. So earlier to that, every effort which was needed mechanically was done with hand, basically with hand. And that is the reason that word manu stuck to manufacturing. But then with the invention of steam, so what the hand was doing, that is actually done by the power of the steam. So there is a revolution which was happened there. And this is called as mechanization. So mechanization means directly from what is made with hand. So we start making it with the help of the machine. Then as the days gone by, the things have changed, and then the demand for the products have increased. So earlier it will be an artisan making a table or a chair or an equipment only for one village or to cater to probably 2-3 villages. But from that scenario, the demand has increased, and then the mass production has become necessary. So later in 1900s, if you see, right from the guns or the pistols which have been used, so from there to the automobiles, so it all been started producing in mass. Then during and after the Second World War, so they found that to manufacture some of the components, and particularly the aerospace components, it's not possible to control the machine tool with the hand. So something more is required. So there the CNC, or in the beginning it is called NC, numerical control technologies have come. And then later we see that the computer numerical controls have come. And most of the efforts which have been done by human being on the machine tool was taken over by the CNC controls. And now we have come to such a stage that we can see the CNC machines which have been built as big as this. Does anybody have seen this kind of a machine? Do you know what is this machine? Though I have given the title, but you know, can you imagine what is the size of this? Yeah, what could be the size? Any guess? Yeah, am I audible? Is it clear or? Yeah. Okay, you're using chat box, so you have muted them all. Okay, fine. Okay, 15 feet, 20 feet. Yeah, that's fine. Even bigger actually. So if you look at the size, I think is professor who is standing here is Professor S.S. Pandey from IIT Bombay. So we can see that such a big and huge machine tools have been manufactured. And Jyoti CNC in Rajasthan, it is right from India, and it is located in our Advanced Manufacturing Technology and Design Center in IIT Madras Research Park, right in our campus. So thus, the way how things were made from small machine tools and mechanization, so now we have transformed into such a big and huge machines which have been controlled by CNC. So on one side, we see this kind of transformation, but still there are some things which are required. Then it is CNC means only computer programming, but it didn't stop there. The artificial intelligence technologies have been incorporated into the CNC technology, and that made the things even more powerful. And now you talk any area in engineering or even in mechanical engineering or in manufacturing, so we see that intelligence plays a very, very important role. So artificial intelligence, so what is this? So artificial intelligence is nothing but mimicking the capabilities of the human brain, the way how we think, the way how we take decisions, the way how we react to a particular situation, and similar kind of things if you can incorporate into the computer, so then that becomes artificial intelligence. And obviously, the human reactions are based on the sensors what we have. So we don't call them literally the sensors, but at least the 5 senses what we have, like vision, smell, touch, and the other senses. Now, in mechanical engineering, what we are trying to do is give all these kind of characteristics or sensing technologies and incorporate them with the intelligence, and with that, so the whole technology becomes very, very powerful. And these days, I think you hear several terms like machine learning, deep learning kind of things. So where we use the neural networks very intensively. So the neural networks actually have the capability of learning. So that is one of the main characteristics of humans. So when we start writing the letter like A for the first time, probably as a child, we make mistakes. But when we do it several times, so we become perfect. Or if you look at a musician, when he plays an instrument, so the sound will be quite horrible. But as he practices, so we see that it is done very nicely. And also many of the musicians we see, they'll be moving around, but still they play the beats correctly. How is it possible? Because of the deep learning, where what they need to do has been incorporated right into the depths of their mind. So thus, on one side, we have the CNC technology. On the other side, we have the artificial intelligence and all the branches in it. So that contributed. And finally, we moved on to an era which is called as automation. So where both the CNC technology and the artificial intelligence combined together, and we use these technologies to carry out the task without the intervention of human being. So that is what is automation. So obviously there are several reasons so why we need to go for automation. Now, trying to consolidate what we have been talking about till now. See, the first revolution, so where the mechanization have come, and that too with the invention of the steam power. So like the weaving looms, or even the devices which have been used for lifting the water and then circulating them. So all these things, the way how they did has been changed. And they never called it Industry 1.0, 2.0 and all. So now actually, when we are in Industry 4.0, so people actually moved back and then gave these names. So thus in the 17th and 18th century, so it has been the mechanization which played the important role. Then the second industrial revolution came. So when the mass production was invented, and the driving force there is basically the electrical energy. So from steam, they moved on to the electricity, and then that was the main driving power, our source of energy. Then came the third industrial revolution. So where we are talking about the automation, the computers, and the electronics. So here the electronics has been dominating. So the integrated chips. So otherwise, actually, whatever the devices, what we are seeing now, will not be able to have them. I don't know if you know that when the first computer was invented, the size of one computer was as big as a big hall. And the power it was consuming is like 160 kilowatts. And it was located in a city called Philadelphia. So where if you turn on that one computer in the nighttime, whole city lights used to get dim. That is called as brownout. And that's the way one computer, if that would have been the way how the things are made, I think we can't imagine having all these technologies. Now, the sizes have come down, the computing capabilities have been increased, and we are today with small, tiny devices we are able to do more than what those days the big computers were doing. So thus there was a technology revolution. Sorry. Yeah. Then came the industry 4.0. So where we are talking about cyber physical system, or what we call it as Internet of Things. Sorry. We're in the office. Hello. Yeah, sorry for that. Yeah, so we are in industry 4.0. So where we are talking about the cyber physical system, Internet of Things, and the main revolution came with the networking of the computers. The first stage is networking of the computers, but that's not the thing today. Now we are connecting not only the computers, but also all the things. I remember actually when we were doing PhD here in IIT Madras. So we used to go to a place away from the institute, go stand in the queue to book the tickets, railway tickets. But now we know that we can do it just with our cell phones wherever we are. How this transformation has happened. So the networking capabilities, so your computing facilities. So like that, the whole way how we make the things and we think has been completely changed. And in industry revolution 3.0 and towards 4, we have been basically talking about computer networking. But when we come to the industry 4.0, and actually now already some of the countries have moved to industry 5.0. So where we see a lot of mass customization and more networking of these things are coming into picture. So thus, there has been a great transformation from the way how things were made with hand, as the definition of manufacturing says, and we stand today in this kind of manufacturing. Now, when we look at the way how the transformation has happened, so we know that the mechanization, the electrification, the digitization, and the cyber physical systems. So these were the main driving forces which have actually led to the kind of manufacturing system what we have today. And also there are different ways they are putting it, like computerization. That was the first transformation. Actually, remember, I think Dr. Raju also will remember when we were in school. So one day there was a holiday. We thought, why this holiday? That is because when they started introducing the computers in the banks, so bank people thought that if they introduce computers in the bank, all the people who are working in the bank will lose their job, and they did the strike. But today, after probably 30, 40 years, when we see the computers are computing and machines are doing their job, but still the humans have the work. But the way how we do, the things have been changed. Instead of doing the more manual labor, so the skills of human beings have been increased, and we do more cognizant jobs than the physical labor. So that is the transformation which has happened. Then other thing what we see is the connectivity. You remember, even today, if there is no network for just 5-10 minutes, so we see all our scholars, everybody coming into the corridors and talking, stopping all their work. Actually, they can do several things without network, but still people feel so handicapped if they don't have the network. And also, like if you go to a place and if there is no network in your cell, you feel as if you are a fish out of water. So that is the way how this connectivity also played an important role.
then the visibility. So seeing what is happening. Now, for example, if you are an owner of an industry, you don't have to go to the factory to see what is happening. You can sit right in front of the computer, and then we can see, visualize and see what is happening right in the industry. That is because of the sensors, the vision system, and everything what we have. Then the transparency. So similar to what the visibility and transparency. Then predictive capacity. It is not waiting for a failure to happen or something to happen, but we can actually foresee it even before that happens. And adaptability and flexibility. So these have become very much necessary because we are living in an age where the market is changing so dynamically, and we need the products, not like in the olden days where the same kind of product used to be there for years together, but now it doesn't work. So either it is an automobile or a two-wheeler or even a consumer product, we see that there are varieties and different styles which are coming up. So otherwise, not be able to survive in the market. Now, my question is, we are talking about what is called as smart manufacturing. What is the meaning of this smart manufacturing? Can somebody define? You can unmute. Yeah, organizers can help them in unmuting. Yeah, you can answer what is smart manufacturing.
But participants can please unmute yourself and you can speak.
Yeah, any answer? Sorry. Yeah, Mr. Dilip Kumar, are you there? Rajesh Rai, Dr. Rajesh Rai. Yeah.
Sir, is it a cyber physical system and
No,
along
sir.
with the digital manufacturing?
Okay, but they are obviously a part of the smart manufacturing.
Okay.
Anything more than that? Yeah, you can answer, or even if it is wrong. Yeah, anyone who knows, you can unmute and answer.
Is it, sir, like enhancing the traditional manufacturing with the modern concepts and modern manufacturing approach and even management approach?
Yeah, that is true. So these are all part, but how do you define smart?
Like along with the digital manufacturing, you're going to incorporate into the traditional systems of manufacturing and then try to like bring out efficiency in manufacturing.
Okay. How do you define this term smart?
There will be feedback. There will be feedback collected. At the same time, the information is conveyed through digital means.
Yeah,
and you're having virtual like reality, augmented reality before the manufacturing process.
Okay. Yeah, I think you are all, everyone are familiar with these terminologies. Yeah, how many of you are familiar with these terminologies? Yeah. Okay, so now I have been talking about what is called Industry 4.0 and all. So what is the difference between this smart manufacturing and Industry 4.0 or 4.0? Yeah. Mr. Christopher. You're there? Yeah, you say something, then we can continue. Dr. Rajesh Rai. Dr. Ravichandran. No, not even single person is whom I'm calling are able to speak or they can't unmute?
They can unmute, sir. They can unmute themselves and speak.
Dr. Vidyasagar Shetty. Dr. Punya Priya.
Yes, sir.
Yeah, so what is the difference between this Industry 4.0 and smart manufacturing? Okay, yeah, it's a simple question. So to see your responses, trying to ask you and get the response from your side. So what is smart manufacturing? Smart manufacturing is a broad category of manufacturing that employs computer integrated manufacturing, high levels of adaptability and rapid design changes, digital information technology, and more flexible technical workforce training and other things for fast changing of the goals and the production levels. See, actually what will happen is if there is any change in the production level, so we should be able to quickly adapt based on the demand and the supply chain. So thus we have what is called as smart manufacturing, which is flexible. Earlier we had what is called as FMS, flexible manufacturing system, but the flexible manufacturing systems were not that actually successful because there were several challenges which has happened, and the adaptability was difficult. But then with the introduction of more computer systems, So that has become possible. Then they started building what is called as smart factories. So which are fully integrated collaborative manufacturing system that respond in a real time to meet the changing demands and conditions. So that is what has become very, very important, because the market is dynamic. So we wanted to make the factory also dynamic. To put in simple terms, smart means if you look at a person and if you call him smart, so what is the meaning of it? So we say that, okay, he's intelligent, he's adaptable. So whatever you ask, he'll be able to answer or react to a particular situation. That is what we call them as smart. So similarly, even in manufacturing, so the system which is able to have all these capabilities, so we call them as smart. Then what is the difference between the Industry 4.0 and the smart manufacturing? It is not much big difference actually. So the Europeans called it as Industry 4.0, then the Americans called it as smart manufacturing. And thus both are talking about a similar kind of a systems. So where we have the computer integration, the automation, the cyber physical systems which have been built into that. And as we have been trying to explain, why do we need these kind of smart systems or Industry 4.0, or now people are talking about 5.2, because we need a degree of connectivity between the levels of automation and in manufacturing. So where the MES systems are called manufacturing execution systems. It's not only the shop floor, but every activity related to manufacturing. Then merging of production life cycle and product life cycle. So you might be been familiar. So product life cycle. So what is a product life cycle? So we are talking about the design of a component, then analysis, then making of it, then producing of that and maintaining it till the lifetime. But all these things have been integrated. So that's right from the design till the end of the life. So we have the fully automated integrated systems and automated operations and management systems. So even the management systems have come under the same umbrella. So thus we are able to have a highly flexible kind of a system and then have large variety of products with consistent product quality, with a lower production cost and with a variety. So these are all have become possible because of the smart manufacturing. And this question I already answered you. So wherein we say basically the Europeans call it as Industry 4.2 and Americans started calling it as smart manufacturing. So now there are several technologies so which have shaped and contributed to the smart manufacturing. So here they have listed some of them, 9 of them, but now actually there are more technologies which are contributing to the Industry 4.0. So the first one is the robotics. So now when we say artificial intelligence or automation, what comes to our mind first is the robots. And the name of robots and artificial intelligence have been more like a synonymous kind of a terms. So when you say AI, people remember only the robot. So that is the way how robots have been contributed. Then additive manufacturing. So this is another technology. Yeah, we'll be looking at them one by one in detail. So just I'll read out the technologies. Augmented reality and virtual reality. Then simulation, then horizontal and vertical system integration, Industrial Internet of Things, that is IIoT, cloud computing, cyber security, big data analytics. So these are some of the technologies which have contributed for the smart manufacturing. So what is robots or robotics? Can somebody give the applications of robots? Can you give some of the areas where robots can be used?
Hello, sir.
Yeah.
Nowadays, everywhere
Mainly
robots are used.
Yeah, very good answer. Yeah.
Even in the hotels, also they are serving foods to the customer.
Yeah, very good. So, right, even from taking the orders to serving the food, they're using robots. Yeah, that's one area. Then, yeah, others.
Sir, in the assembly line for assembly purpose.
Okay, assembly purpose, very much like if you take any product, so assembly line they use. By the way, in assembly lines, what is the type of automation they use? Is it semi-automation or fully automated systems?
Both semi and the fully, sir. It depends on the work.
Yeah, very good. So in many of the cases, semi-automation works out very cheap and well because humans are more flexible. So if you look at the car assembly, so the final stages actually humans also will be there. So obviously assisted by the robots. And there are smaller products, so where it can be fully robot assembly. Yeah, both are right. Yeah, then what are the other applications? In hospitality industry, in assembly, 2 applications I have. So what are the other things?
Sir, some options are posted in the chat box.
Okay. So chat box, welding, painting, surgery. Yeah, very good. Anything more than this? Yeah, as someone has said, it is almost there in every field. So if you take construction field, so people started using the robots. So construction industry is actually earlier it was not very well organized. So you know that construction industry is not like manufacturing, but then they came up with an idea. So where they wanted to make even manufacturing industry like, sorry, the construction industry like manufacturing. But that was a big challenge. But nowadays in many of the countries, so they started building the houses and the buildings just like how we build. So within few hours, we can see that the buildings have been made. Okay. So evening, like in the morning, while going to your office, you don't see anything there. But by the time you come in the evening, you can see a building. So that is the way how the things have been changed. And also we have what is called as a cooperative manipulators. So where in the construction industry, like if you want to lift very big, heavy weights, so traditionally, you know what people used to do? So some people will hold on one side, other people will hold, and then they'll be shouting, oh, left, right, or up, down, keep it like that. But now that task is actually very easily done by using the robots. So they communicate with themselves and they will be able to cooperate and then do the things by themselves. And very simple operations like pick and place, so they can very easily do, and also sort the objects. So with the assistance of the mission vision, so we can actually use them for pattern recognition Have you heard this term? Pattern recognition, and then we can use them for sorting of the things. And welding. So this is another area where robots have been very popularly used. And here also you can see that 2 robots are holding and 2 robots are welding. So that's the way how they make the part to be accessible for welding. So that's the reason we need to tilt. And all these things, all the robots are cooperating to each other. There were even simple robots like this. And not only that, nowadays, we are using the robots for inspection. So inspection and metrology is one of the area which is very, very critical and very crucial. So if you want to maintain the quality, so the inspection plays an important role. And if you want to know the process, to understand the process, inspection plays a very important role. So how? I can tell you the example. If you are doing milling operation, if you want to know whether the milling process is going on well or not, just take the chips which have been produced, the machine chips, and observe them. You can tell whether the process is good or not. Even look at the surface quality. When you look at the surface, you can say whether the process went on well or not. So thus, inspection gives insight into the process, not only just the product, but it gives insight into the process itself. So thus, nowadays, when you're talking about high quality and consistency in quality, so we need to be very careful looking at not only the finished product, but the process themselves. And the inspection gives an insight into that. And here we can see how the robots can be programmed to carry out such kind of tasks. So some of you have put mining, then medical field, welding, painting, surgery. Yeah. So like this, there are several areas where we can use robots. And robots can also be used for painting. Okay. So like if you have a photograph, you want it to be drawn, we can do that. You may say it is a simple task, but it is not. You know, the human curves, so we call it as a sculpture when they make the human figure. So the sculptured surfaces are free-form surfaces. So probably when you look at the other slide, I think that is not here. So we can understand that these curves are more free-form. The profiles of the human face or even the body, when we look, it is a free-form surface. So drawing them is not that easy. Drawing a straight line is fine. Drawing a circle is easy. But making the sculptured surfaces, I think in design, you would have studied some of them. By the way, have you heard the term what is called as NURBS? NURBS surfaces. What is NURBS? Can somebody explain? Yeah, what is NURBS surface? Yeah, anybody who studied CAD, I think all of you should have. Because nowadays the products what we get, most of them have these surfaces. Yeah.
This may be a 3D geometry
Yeah, that is right. But what is the long form of nerves? Yeah.
It is a non-uniform something.
Yeah, non-uniform rational B
Oh,
spline.
yes. Non-uniform rational splines, B splines.
B splines, yeah. So actually, in the free form, we had like splines, but those splines are not sufficient, like cubic splines and all, are not sufficient to meet the requirements of the surfaces which we are designing. When you look at the space aircrafts and even the spaceships, so we need a higher order curves and the integrated representation of any curve. So right from a point to a circle to ellipse or cycloid or any freeform surface, we can represent them by using NURBS, that is non-uniform rational B-spline curves. So initially we had only spline curves. So then B-splines came, then rational B-splines came, then uniform rational B-splines came, and then finally the non-uniform rational B-spline curves. The mathematical representation is a bit complex, but they can represent any shape. So thus, nowadays, if you take any CAD package, so the freeform surfaces have to be, that has been made mandatory, have to be representing them by using the NURBS representation. Okay, the medical applications, I think we have several of the areas in medical, they have been using the robots. So I have just a small video which I'll just show and then move on. Okay, just 1 minute. Can you see the video? Are you able to see the video? Any response? Are you able to see the video?
Yes, sir.
Okay, sound, are you able to hear or no?
No.
No, sir.
Okay, fine. Anyway, in this one, there is no sound, but later I think we need to do something to make. But anyway, this is only a text, which is sound. Yeah. So thus we can see that there are several ways how robots are being used in the medical field. So medical field is one of the area so which uses our engineering technologies to the maximum extent. So even if you go to a dentist, the way how they drill the tooth, so it is like a micro machining. So where they have a small drill bits and then they use it. And if you go to an orthopedician, the way how they work, it is similar to what we do in a carpentry shop. Okay, so they have the hammer, the things, and then the way they handle it's almost similar to that. So thus, engineering actually has influenced a lot in the medical field. And also, if you, I don't know if you have heard these terms called pinhole surgery. Have anybody heard this term? Pinhole surgery? What is the meaning of that? Yeah.
Not heard, sir.
Oh, never heard? Okay. So actually, these days it is possible to make a very, very small incision, like a small hole, insert all the micro devices, surgical devices, obviously a camera also, and carry out the whole surgery with that small hole. And then maybe only single stitch is required. And with that, you can complete the operation. So how they work is, for example, if there is a kidney stone, if you want to remove, so they make a small incision. So insert these devices and they will have actually the vision system. So where we can see where it is going. And then when it reaches near what we call it as a kidney stone, so there'll be a knife which was like folded first, then it expands like a cutter, then it rotates, breaks that, then whatever the blood or this particle, they'll be sucked out, and then the cutter will actually again goes back to the initial position, and then it will be slowly retrieved back. So thus we can carry out the surgeries with a small incision. So that is called as a pinhole surgery. So like this, there are several developments in this area. Okay, I wanted to ask you a question. Have you heard this term, what is called as cobot? Have you heard? Robot, I think you're all very happy and replied. But what is a cobot?
Sir, it's a robot which can assist a human worker in an industrial environment.
Yeah, very good. So what is the meaning of co?
Collaborative.
Very good. So I think you're familiar with this term. So collaborative robots. So they are called as cobots. So these will interact with the human beings and then work together. But earlier it was not like that. I think even in our IIT Madras, so we purchased a KUKA robot. So KUKA is a Japanese company, which is an industrial robot. So when we install that, sorry, you know what is the first instruction they gave? So we need to build a fence around it, and that is actually an interlock. So wherein when you close the gate, the whole fence gate, only then the robot starts moving. Otherwise, even if you make the program and give the command start, it will not move at all. So why? Because it's a heavy industrial robot, and when it is swinging its arm, if somebody are there, it will just hit and it will be fatal. So that is the reason they need a fence, they need all the interlocks which need to be set, and see that there is nobody, then only it will start. But now the robots are not like that. You can actually have the robots right in the place where the humans are there, and humans and robots can work together. So that is the reason it is called as cobot, collaborative robot. And how is that possible? Now think that there is a big industrial robot like this, and it is moving its arm very fast, doing its task. But suddenly if there is a human being, you know what it does? It's not going to hit. It will have sensors. It will know that there is an obstacle, and immediately it will brake. The brakes will be applied before even coming close to that human being or any other obstacle. So obstacle avoidance. So that is the way how the robots are designed today. And thus robots, along with the humans, they can work in the collaborative environment. So this gives actually a lot of flexibility and responsiveness, where you can tell what robot need to be done, and we can also carry out whatever the tasks which are required for us. So these are the cobots. And there is an interesting video. You can just have a look at it. This is called self-assembling robots. They can even jump. Yeah, a lot of technology has gone inside that. So where they are called self-assembling, self-reconfigurable robots. So you want to make any shape, depending on the task which they need to perform, they will come together and then form into their shape and then go ahead doing the task. So thus a lot of intelligence, autonomy has been built into robots. Any questions or doubts? Any other comments?
Participants, if you have any questions as of now, you can please post them, or you can unmute your mic and ask the speaker. Sir, no questions have come as of now. I think you can continue.
Yeah, okay, good. So the next area, so which has contributed the most is additive manufacturing. Okay, can you give at least the alternate names for this additive manufacturing?
Rapid prototyping, 3D printing.
Yeah, rapid prototyping, 3D printing, any other name? One more name, familiar name is there? Layered manufacturing. So because we can do it layer by layer. Now the way how the things are made, if you see, I think additive manufacturing is another technology which has brought such a kind of transformation, the way how the products are made. So in the conventional manufacturing, so we call them as subtractive manufacturing. So where if you want to make a hole, or if you want to make a cylindrical block, so we make a block, take a block, then machine out wherever we need the spaces. And that is not actually right, because we are wasting a lot of material. But in this additive manufacturing, what we are going to do is we build the wall only where it is required. So thus, there is a lot of revolution in this simple technology. So we build only where it is required. Obviously, this is still coming up area. 3D metal printing is very challenging, and there are several rather challenges, instead of calling them as limitations. There are several challenges which need to overcome so that we can make it into a mature technology. But still, the way how things were made have been transformed by using this additive manufacturing or layered manufacturing. Earlier, it was only used for prototyping, so it was called as rapid prototyping. And how this transformation has been brought is right from the 3D model. So we make into a dot STL, so where it's a lithographic kind of files. It's also called as tessellation file. So you know what is, do you know what is the term tessellation means? If you are familiar with geometry, CAD.
It's dividing the surface into small triangles.
Yeah, very good. So we can divide that surface into small triangles, and then we generate the STL file. Then later we slice it in a layer, and then we make the tool path so that it can print them. And finally, you have the object. In most of the cases, so wherein we can use the part as it is, but in many of the cases, we need the processing, further processing. But that is good enough, because if you are producing only few number of parts, so we don't need to make the dies, we don't need to take a lot of time for writing the CNC code and other things. The almost right from CAD till 3D printing, it's direct. So we don't need to have a human intervention. So we'll be able to produce the parts. So thus, again, if I say what are the application areas, you can name any of them. So as you said, for robots, so this is another area where every area, right from consumer products to aerospace industry, so people started using the parts which are made by 3D printing. What are the advantages? So we can have complex shapes. It's a very versatile and flexible kind of process, because you can produce any parts with the same machine. Then elimination of component assembly. So here assembly can be very easily carried out. And also we can make the internal parts, moving parts. So which is generally sometimes in the beginning when the 3D printing technology has come. So some of the scientists, people brought the samples. They will ask how there is a ball inside a ball, but without any joint on the top. So we used to wonder how they made that. But now we know that by 3D printing, you can make that kind of parts, you can print them very easily. Then zero skill manufacturing, we can question that, but at least less skill manufacturing. Then compact and portable. So you want to have a parts, you can actually take the 3D printing machine there and then print. And low waste, because we don't have to waste like in the form of chips, usually in a subtractive manufacturing. So we'll be wasting them a lot of material. But here, that kind of waste is not there. Obviously, in some places, we need a support structure and other material losses will be there, but that is a small amount. but there are obviously several limitations because you can't use all the materials. So nowadays, actually, 3D metal printing is possible with the help of powders, but getting that powders themselves is a big challenge. So even difficult to machine materials like titanium powders are available. So we have actually in IIT Madras, we have the 3D printing based on the laser 3D printing equipment. So where we use 2 powders. Actually, we can feed 2 powders and combine them and get a product like a functionally graded material we can print. So thus nowadays we have to much extent different powders, but it is still limited. You can't get what powder we need. Then high cost at the industrial level. So if you look at a metal 3D printer, it will cost anywhere from 4-5 crores to and above. So thus they are obviously at this stage they're expensive. And also secondary processor are very much required. So you need to probably machine them or heat treat them because their structure is more porous and it's not as dense as the other machining process. By the way, one question, you're all mechanical engineers. Which of the processes, manufacturing process, will give the most dense material? When we do which process? From the primary, tertiary, or tertiary, secondary or tertiary operations, manufacturing process. So when I make with this particular process, so I get a very dense structure, material structure. And which is that process? Yeah, answer. There is a lag, is it? Response I get after which time? Are you able to hear my question? Yeah, waiting for response. Yeah, tell me which is that process. You name at least some of them. By doing this, we'll get very dense material. Yeah.
Sir, there was a network issue from our end. Can you please repeat the question, sir?
Yeah. So when you produce the parts with the different processes, machining processes, or whatever the process, what we have, primary, secondary, tertiary process. So which process, when you make, the material property will be very, very dense. The material will be dense. So now we have been telling that when we do 3D printing, so it's a porous, it's not highly dense. Which of these mechanical process will give us the most dense particle structure? Is it like when you do metal cutting or welding or some other process? So I get the best properties in the material. It will be very dense.
Powder metallurgy, sir.
No. Powder metallurgy, again, there'll be problems. No, like 3D printing, we use powders. Okay. So we get by compacting it to some extent. Yeah, the most traditional process is forging. You're right. So compact, yeah, sintering and then applying the force that is there, but that will stand as second. So the first one is forging. So then later, actually nowadays, they are trying to make dense material by using the powder metallurgy. You make like a powder. So either sinter to the temperature and then apply the pressure and compact it. But the most naturally by forging, we can get that kind of a very dense structure. But with the 3D printed, still the density is not that high, but people have been trying to make it more dense. So other products, what we can make by using 3D printing is customized products. So obviously there are several engineering applications. So right from the aircraft seating. So nowadays actually, so all the interiors, if you see, most of them are 3D printed. And most of the materials are, you know what is the material basically used in aircraft nowadays? Earlier it was aluminum alloys, the body, the structure and all, but nowadays, you know what is the material? Yeah.
Is it ABS?
ABS, no, not ABS, but a school or a category of material, class of material.
Is it composite, sir?
Yeah, composites. So we are living in an age called as composites age. So earlier it was like Stone Age, then Bronze Age, then Iron Age, then Plastics Age, then now we are in composites age. So if you see 10 years, sorry, not 10, like 30 years back, every product, whatever we see was with the plastic. So it was the prices were very low when compared to like wooden or metallic one. So thus plastics have revolutionized, but now it is the composites which have been revolutionizing. All the interiors and even the structure of the aircrafts are all made with the composites. Yeah, as we move on, so there are still several hundreds of examples of products of 3D printing. So I just removed the slides because of want of time. Otherwise, right from a tiny screw component till the buildings, you can even construct the houses by using 3D printing. And in other applications, right from printing your birthday cake to making the components for biomedical applications like implants, we can do them by using 3D printing. So thus the areas are very wide. Okay, now moving on to the third technology that transformed and brought us to this level of automation. This level of automation is not simulation, but this is the initial step. So can you define what is simulation? Yeah, can someone define what is simulation?
ಫೋನ್ ಮಾಡಿ ಅಲ್ಲಿ ಚಾಟ್ ಅಲ್ಲಿ ಹುಡುಕ್ತೀನಿ ಅಲ್ಲಿ ಲಿಂಕ್ ಖಾಲಿ ಇಲ್ಲ ಇಲ್ಲ ಅಲ್ಲಿ ಕೊನೆ ಮತ್ತೆ ಮೆಸೇಜ್ ಹಾಕಿದೆ ನಾನು ಮತ್ತೆ ಅವರು ಇವರು
You can mute if that is in this one, but you can allow them to interact because interaction is very important in a classroom. So I want my class to be interactive, but not disturbing. So only those things you can take care. Yeah. So what is simulation? Mr. Rajesha. Yeah, you're unmute. Your mic is unmute. You can speak. Miss Asha. Mr. Christopher, I didn't hear from you. Are you there? Dr. Vasant Kumar.
So before manufacturing, we can find out the stresses on the strain.
Stress strain, okay, and that I can do by using finite element analysis. But how is simulation different from that? Yeah.
A process, sir, imitating the actual process.
So is it an imitation of a system or a process?
Yeah, that's right. But now there is a term called animation. So can you tell what is the difference between simulation and animation? What is the difference? Have you heard this term animation? Yeah, anybody who knows, you can tell. Mr. Harshit.
Animation is just for the visual appearance.
Yeah.
Whereas simulation is when we analyze and get to know the results, which are very much similar to the real life events.
Yeah, okay, fine. So animation is only like computer graphics. So where you can see the graphical images, but you will not have the technical data. Like for example, so Jurassic Park, I think, was one of the first movies which they made. So there, if a dinosaur is walking, you can see them walk, but you cannot calculate the stress or the strain. Okay. So thus simulation is more engineering. So where we can simulate a real life situation and then get the engineering properties. So thus we have a system and then we have the inputs and we have the outputs. So we'll be able to realize the real life situation and analyze it. So thus this is called as a simulation. So I think there are several applications of them. So where system simulations have played a very, very important role. But now we are moving on to what is called as virtual reality and augmented reality. So usually they use the acronyms AR and VR. So that's what they say. So, okay, if I ask question, I think it will take time. Or can somebody quickly tell what is virtual reality and what is augmented reality? So what is this AR and VR techniques? What is augmented reality? What is virtual reality? I think nowadays all the cell phones, Apple phones and all come with augmented reality. So what is that? At least tell what is virtual reality. Yeah, if you say something, I can move. Otherwise,
in virtual reality, where you are going to do the CAD models.
You are
No,
going
CAD is a model, so it is not reality. No reality is there, so it's a model.
through utilizing the computer, you are going to create that whatever the things you want to project in the computer softwares. That is virtual reality. Whereas in augmented reality, for actual scenario, you are building up extra things that we call it as augmented reality.
So what is that extra things?
For a workspace, you are going to add some extra things that whether it will fit or not, like that you can check.
Yeah, I think you're giving the application right. So, but slightly, yeah. See, the computer environment is one. Then the virtual reality is little more than that. Maybe if I give an example, probably you will understand it. See, one day actually, when my elder son was there, so those days the computer games were very familiar. So they used to play the car driving games. Okay, so there'll be a driver, and then they drive very fast. They'll go hit a pillar, and then they fall. Then driver comes and then goes. So one day, actually, when I was driving a car and stopped, then my son said, "I can also drive." He was like 4 or 5 years. I was surprised how. Then he says that no, I can drive in the computer, so I can also drive here. Is it true? See, what you see in the computer is only graphics. So there you may hit something, but still the driver will get up and go. So thus it's only limited to computer. But in virtual reality, we bring a component where, for example, the flight simulation. So wherein if the pilot is there sitting in that simulator, and if he steeply dives the aircraft, actually he himself will feel that. So how do they do? Below him, there'll be a hydraulic jacks, and then they will actually come down sharply, and he can feel the acceleration, deceleration, everything. So thus, if it is only computer, it will be like a child thinking that I can do great things. He can drive even a flight. That's what he'll think. But if you put them in the virtual reality simulator, so they will also feel. If they turn the aircraft like steeply to the right or left, they'll be thrown out of the seat. So thus, it's not computer environment, but make the operator or the person also to feel what is happening in the computer. Then that is virtual reality. So then later, I think 3D movies came. After that, 4D, 5D movies came. So in that, how they simulate this one is, if there is raining in the movie, so they'll have the showers and then put water. If the wind is blowing, so they'll have the blowers and make us to feel. So thus, we also become a part of the computer environment and we can feel. So that is virtual reality. Then augmented reality. So the computers nowadays, or even the cell phones, have the capability to combine the virtual and the real. See here, they give an example of what is this character called? That yellow one?
Pikachu. Pikachu. Huh? Pikachu.
Yeah. So they made it to be seen as if it is really standing on the road. So nothing is there on the road, but still road is real, but this image is not real. So thus augmented reality and virtual reality both have been combined. You may ask, what is the engineering application? Actually, we have a company here. It's a Caterpillar company. They have a design center close to IIT Madras in a park called Ascendas. Okay, research park. So they have a virtual reality cave. They were explaining like, what is the use of this one? See, it looks like when they make these earth movers, when they're going and making the tunnels, so many times the arm will get stuck in the tunnel, and then it takes a lot of efforts and waste of time to retrieve it back and then put to work again. Why that has happened? Because it has made a wrong move, so it went and got struck. But nowadays what they are doing is, they take the images of the real images of the cave, they rebuild the 3D of the cave, and then they also have the virtual models of the earth mover. So then they simulate all the movements right in the computer in that cave, and then see if they make such kind of a movement, so it is going to get struck. So they will not make that movement. So thus later they'll send the same program to that machine. So they make the same movements and they can work efficiently. So thus this virtual and augmented reality have a lot of engineering applications in making the job much easier. So thus simulation, virtual reality, and augmented reality. So all these things have been put and then made use. And some of the companies even made a statement that with this method, the accuracy of engineers can go up to 96%, and they are able to do the work 30% faster. So thus they can see the implementation in the real world. Any questions till now or any comments? Okay, so to save time, let me continue. So then to achieve the smart manufacturing or a smart factories, to build them, we need what is called as horizontal and vertical system integration. Earlier, if you see the traditional manufacturing, so the center of manufacturing is a machine. But nowadays, it is not machine. It's actually the computer systems and the data. Data becomes very, very important. I'll tell you how. I think a few days back, which is the airport. So one of the airports, so the computer system failed. So when that happens, you know, there are people, there are aircrafts, there are luggages or load, and there are the carrier aircrafts, but they don't know where to put where, what to put in which aircraft. So thus there'll be a lot of confusion. Though all the infrastructure is there, if the computer system is not there, the data is not there, nothing can work. So everybody is stranded and all the goods lying there and rotting, you can't do anything. So thus these days, the data and the computer integrated systems play a very, very important role, not only in manufacturing, but in every system where the computers are playing a key role. So thus in manufacturing, so we have an integrated architecture. So where around this data, all the other manufacturing systems have been built. The shop floor activities, the automation activities, and also the other ERP, enterprise resources, all built around that. So thus, we need to integrate these systems. We can't work in separate cells, but every activity of an industry should be brought under one umbrella. And that is what the automation helps in doing that. Unless that is there, you cannot think about the complete automation. So here they gave an example how what is horizontal integration and what is vertical integration. So the processes have been integrated, and different stages in that process are also integrated. So thus it is a both horizontal and vertical integration that has taken place. Then the sixth technology, it is Internet of Things. We know about networking of computers. Okay, so ARPA network, the American network. So it all started in 1960s and 70s. So where they started connecting the computers with the network, and that almost revolutionized the whole way how we do the things. And that is one of the greatest inventions of the last century, networking of the computers. But now what we are talking about, it is not just networking of computers, but it is networking of things. What is the meaning of it? Now, if you have an industry, so the air conditioner in the industry can talk to the lighting system, or the lighting system can talk to a machine, or the machine can communicate to the thermal system. So thus, it's not only computers, it's not only interaction between computer and human being, but everything. So even lights, it can talk to the lights, or even talk means it can connect to the lights, or it can communicate with the lights. How is that? For example, if there is a machine which is producing a lot of heat and the temperature is going up, so it can send a signal to the air conditioner telling that I need more cooling. So increase that cooling. So thus you lower the temperature automatically and AC starts working more and heat will be removed. So there is no necessity of human intervention there. They can communicate with themselves. So that is Internet of Things. Then IoT is Industrial Internet of Things. So where all the systems on the shop floor can talk to each other. And these are also called as cyber physical systems because cyber means it is actually zero. Cyber means zero. Cyber systems means computer systems. Then cyber and physical systems. So both can actually interact. So thus the term Industrial Internet of Things. So where we see that IoT, in IoT even house, I think nowadays we know that even through Wi-Fi, you can talk to the washing machine or even the dishwasher, what we have, or to a TV or even lights are all nowadays have the sensors. So thus they can become a part of network. And if you look at devices like Alexa and other devices, so we can communicate with them and interact. Though it is a thing, but still it communicates, maybe in the verbal way or in any way. So thus it's all possible. So we have Internet of Things and also Industrial Internet of Things. So where every part of it has been connected. And also actually the data is in the cloud, not anymore in the hard disk. So Alexa is another virtual device. So where it has no memory. So if network is not there, it is dummy. So because everything is connected in the cloud. Cloud means it is there in the server somewhere, but not on your hard disk. And all these things are connected, but everything is connected through the network. So thus the systems are becoming very complicated. I'll show you a video. And so where you can see a concept car where the car can interact with the humans, and then it can even take us to the required destiny. Are you able to hear the sound or no? Can you hear the sound?
No, sir.
Okay, then. While sharing, we need to share sound.
Hello. Hello.
Yeah, now tell me, can you hear the sound? Video sound.
Yes, sir. Yes, sir. Can you
Yeah.
Hello, I'm Eleanor.
Hello, Eleanor.
I've arranged a brief tour to collect the shoes you ordered for Charlie's birthday. You hadn't forgotten, had you? I'm ready when you are. We will be arriving in a few minutes. You do have an early start in the morning. Enjoy yourself. I'll be here waiting for you.
Yeah, this is actually a concept car. How nice it will be. You don't need to drive. So you don't have to do anything. So just go. As you go, the doors will open. You sit there and tell where you want to go. So it will take and then leave you there. So all these systems are completely automated. So nowadays we have that kind of an automation which is possible. So it looks almost like a dream, but now the systems are coming up to that kind of a stage. Then one more technology which is important is called digital twin. So where like a physical twin, what we call, we can make a digital twin which exactly behaves like the real system. Actually, we have a new project which is called making of an autonomous factory with the help of digital twins. So wherein the physical systems are there. So every part of that system is represented on the computer, and exactly how the physical system will behave. So even the computer will behave. And if you want to predict, we can say, do that by using the computer model, and exactly it will do the same thing in the physical model. For example, if you have a digital twin of a aero engine, so now simulate and see that whether when I'm going to fly it continuously for 24 hours, whether my engine is going to fail in next 24 hours or not. Do it on the computer. If it is fine, you run the flight, it will be fine. So later, see that if it is failing, so then you may have to take action, but if you don't do anything, probably the flight may fail. So thus, the real system and the digital twin will behave the same. So thus the digital twin will help us in what is called as a predictive maintenance, and also to represent the exact physical system. So nowadays, they say that it is a lot helping in the industry. So where people have been asking for that. So we also have a new project, so where we are trying to make the digital twin of a robot, an automated guided vehicle, AGV, and a CNC machine, and a 3D printer, and connect them virtually. And we should be able to simulate everything what happens on the shop floor by using these digital twins. There is another video, small video. You can just have a look at it.
Imagine a world where industrial facilities and production are optimally controlled through a convergence of the digital and physical world. A network of machines working side by side and collaborating seamlessly with people who are freed up to perform more creative tasks. This is smart manufacturing, powered by industrial IoT. At Cognizant, we drive innovation in manufacturing operations, from R&D to production, sourcing to delivery, and product monitoring to new services. We've successfully guided our clients to develop more efficient, human-centered operating models. Our approach prioritizes customer data and gathering it from multiple sources to develop actionable insights. This leads to improved solutions that allow manufacturers to respond more quickly to their customers. We've worked with a leading packaging equipment manufacturer to help them remotely monitor thousands of machines and detect and prevent service bottlenecks. This increased service parts revenue by 12%. A global farm equipment manufacturer to visualize all aspects of their sensor-enabled production line. This addressed problems in real time and accelerated output of new products per machine by nearly 50%. And a multinational leader to retrofit and IoT-enable their refrigeration equipment. By remotely predicting service needs, they reduced response times from 5 hours to just 20 minutes. And they reduced product waste by 10%. Cognizant is leading the digital revolution in industrial IoT, transforming organizations and enhancing revenues with new ecosystems and business models. Now is the time for us to help you get started on the path to improved efficiency, better customer service, and increased growth. By connecting real-time data to real-time outcomes, Cognizant can make your vision a reality.
Yeah, so it's not the company which you are advertising, but the concepts. So what they have been forming. Okay, then we have 10 more minutes, so we'll quickly look at the other technologies. So cloud computing. So this is another way how both the storage and computing is actually made in the cloud. So what is the meaning of cloud? That means it is networked and your servers or the processors are not in the hard disk or in the system, but they are done virtually. So this is called as the cloud computing. I think there's one more video. If you have time, we'll show you in the end. Then other concept or a challenge, what we need to face. See, now when we have the whole data and everything in the cloud, so it becomes so big challenge that how do you maintain this security? So nowadays, actually, there is a lot of funding available for developing these security systems, cyber security systems, because that becomes very much necessary. So without that, all the systems, whatever we are talking about, will not be able to work. Then the last one is the big data analytics. So where people have been talking about this technology, wherein when you look at an industry or any system, if you take so much of sensors we are talking about, so many systems, and every system is continuously producing a lot of data. But the question is, what do you do with that data that is too big and too complex to handle? Like if you go to a hospital, if a patient is not good, so nowadays what they do, they connect all the devices. So where you get the heartbeat, the pulse rate, the breathing rate, and everything. Then when an expert comes there, when he looks at all those things, he will say what is the condition of the patient. And in a similar way, now if you have a digitized data, like all graphs running continuously, how will the computer be able to analyze that and come up with the inference? If it doesn't do, then the data has no meaning. So thus, nowadays, this has become another challenging area. So where people are trying to develop the algorithms and obviously the intelligent algorithms. So where we'll be able to get the inference out of that data. Otherwise, the data is meaningless. So that is a big area which has been coming up. And if you can do that, it can have several applications. So right from optimizing the production and enhancing the efficiency. So if we can analyze the data properly, so we can optimize. So wherever there are losses, you can cut down and we can increase the efficiency. And the second one, predict machine failure and reduce the downtime. So when you have the trends, so we have the signatures of the machine tool, we can know when it is going to fail or when it is tending towards the failure. Even for a tool, if you get the dynamometer signals, so we can understand quickly that, oh, the cutting forces are going high. It's because tool wear. And if you continue, it is going to fail. So these kind of things we can very easily predict. And we have what is the area called prognostics. So where we can predict even before the failure occurs. Then optimize the supply chain. This is another big challenge with the logistics. So where ERP means enterprise resources planning. So and implementation, it's a big challenge. But nowadays they're analyzing all these systems and see how they can improve the efficiency of the supply chain. So here they say that only 17% of supply chain executives implement big data analytics. And if they do it, they can actually get a very high efficiency. Okay, so that's with the help of all these technologies. So we have come to a level where initially the manufacturing is meant of doing with hand, but now we have been talking about doing everything without not only just hand, but without the intervention of human being. So if this kind of development continues in future, we look forward to develop a new type of technologies, processes, and systems to revolutionize the way how the products are manufactured and how these machines will interact with the human beings. So thank you very much for your attention. So hope you are able to understand, get the useful information from this lecture. Thank you. Yeah, over to the organizers.
Thank you, sir, for the discussion. Now the floor is open to the question and answer session, and I request all the participants to please post your questions in the chat box, and also you can unmute and ask your question to the speaker.
Good morning, sir.
Yeah.
Yeah, this is Dr. Roshan Kumar. So almost 2 hours we are interacted with you, sir. Very informative session.
Thank you.
So I have a question, sir. Actually, it is very general. So even though a lot of technologies, so there is a drop in mechanical admission, sir. So what is the main reason, sir?
Yeah. So see, actually, one thing is that it's mostly a kind of a wave. So where there are ups and downs in any of the branches. So time to time you have seen. So at one time, when we see, I think the civil branch was the most popular one in the beginning. Then mechanical, then the traditional branches came. So once this IT revolution has happened, so all the IT branches and circuit branches, so they have picked up. So now the peak is for them. Mechanical, it looks like as if there is no demand. But over time, what happens is, how long you can just have this virtual kind of a system. So how long you will just develop only the AI system? Where is the physical system to realize that? So thus, the demand is going to come back. So sometimes when it is a low, you need to hide. There is no way about it. So we have to take it. It's a reality. But days are going to come. So where again, the demand will increase and then it will balance out. So no wave is it is same. So if you see some of few years back, I think it is around 2000. So when we just completed our PhD, when you're looking for the jobs, only IT jobs were very popular. And actually, we are basically from Andhra, but let me comment it. So whenever we are looking for a girl or somebody, so they used to say, we'll give a girl only for computer, that IT company person or working in IT, because they had a lot of perks and their lifestyle looked to be much better than all other even government jobs. But then later the things changed. And nowadays, when you talk to the people, they say, no, if he's in IT, I'm not going to give my daughter in marriage. So the way how the things have changed is entirely different. Now people are looking for government jobs and other things. So thus this kind of a trend will be there, different fields. So that ups and downs will be there. We should be able to take it up. But for a few years, it may be a difficult time, but there'll be times where there'll be a balance. And the better thing what we are doing now here is, don't make mechanical look like a kind of a shop floor and only doing with these machines and all. So make it ITized, somebody said. So make it more like a computer based. So that's what actually attracts the youngsters. So talk about these kind of a technologies, what we said, robotics or artificial intelligence in industry. So they think that artificial intelligence is computer science. No. See, if the computer science student is there, and then if there is a mechanical student, so to whom we teach artificial intelligence, when you go for the placement, obviously they'll select mechanical engineer because he knows how to implement the AI to a practical system rather than theory. So thus, mechanical engineers will be in more demand if only we can make them more computer science integrated with mechanical. So change your syllabuses, change the way how you project. Don't just say mechanical means only machines and these things. So have the areas like robotics, 3D printing is highly picking up. So what engineers we need? Obviously, with a CAD and mechanical engineers are required. And robotics is another area, virtual reality, and all these technologies, AR, VR, whatever I have been talking. So they're all actually mechanical engineers. So have computer skills. So that is the most advanced system. And also now I think there is another area which is called SCADA. So where you can have controls and automation put together. You'll be able to have a lot of job opportunities in the industries. Okay. So that's ITI is the mechanical. So don't project it as just something which has to do with the machines. Yeah.
Okay. Thank you so much, sir. Thank you for the information.
But anyway, it is out of syllabus. That's not the topic, but with whatever experience I have said. Yeah. Okay, I think if you don't have any questions, we can close.
Participants, any other questions? Please, you can ask.
Yeah, I think we have made it interactive, so probably it's fine. Yeah.
So there's one question in IIT Chennai. I think a few months back, they had inaugurated a 3D printed home. Was the project under your department, sir?
There are several 3D print. So we have actually in IIT Madras, we have mechanical, we have metallurgy, we have engineering design. So all of us are dealing with the 3D printers. So since mechanical actually was big, it is divided, like aerospace is different, metallurgy is different, applied mechanics is different, engineering design is different. So to have that huge kind of a population on the faculty, so it has been divided into different departments, and most of each department actually deals with the 3D printing in their own way. See, for example, we have a center of excellence in laser material processing. So the 3D printer, what I use is based on a 2 kilowatt laser. So there could be other even biomedical. They have been using the 3D printers to print brain or organs and other things. So thus 3D printing is not only just mechanical. So every branch has their own 3D printers.
Okay, thank you, sir.
Yeah.
Now we come to the end of the program, and I request Dr. Kenneth Sherwin, Assistant Professor in the Department of Mechanical Engineering, SGAC, to give the vote of thanks.
Before that, I should thank him. Good afternoon, one and all. It gives me a great pleasure to propose the vote of thanks on behalf of the Department of Mechanical Engineering. I would like to thank Professor Samuel GL, IIT Chennai, for accepting our invitation and delivering a lecture on smart manufacturing. Truly, it was a very informative session, sir. I also thank all the participants for actively participating in the session and also logging in on time. I'm sure that this session would have helped you. Please join us for our next session in the afternoon at 2:30 p.m. Thank you, one and all.
Okay, thank you. All the best.
I request the participants to please fill the feedback form, as links are being posted in the chat box.
Yeah.
Thank you.
Okay, thank you. I think
smart presentation and smart manufacturing. It was really a wonderful presentation. Nice to
be here on this platform to learn many things on smart manufacturing.